Question 3. What is the difference between type 1 versus type 2 error? Answer: is Ha true? No, H0 is true, Ha is negative, Tn, yes, H0 is false, Ha is positive, Tp. A type 1 error occurs when the null hypothesis is true but is rejected. A type 2 error occurs when the null hypothesis is false but erroneously fails to be rejected. Here is the chart of type 1 versus type 2 error. From that you can easily understand it.
Question 4. What is linear regression? What do the terms p-value, coefficient, and r-squared value mean? What is the significance of each of these components? Answer: imagine you want to predict the price of a house. That will depend on some factors, called independent variables, such as location, size, year of construction. If we assume there is a linear relationship between these variables and the price, our dependent variable, then our price is predicted by the following function: y equals a plus bx. The p-value in the table is the minimum. The significance level at which the coefficient is relevant. The lower the p-value, the more important is the variable in predicting the price. Usually we set a 5% level, so that we have a 95% confidentiality that our variable is relevant. The p-value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. A smaller p-value means that there is stronger evidence in favor of the alternative hypothesis. The coefficient value signifies how much the mean of the dependent variable changes given a 1-unit shift in the independent variable while holding other variables in the model constant. This property of holding the other variables constant is crucial because it allows you to assess the effect of each variable in isolation from the others. R-squared is a statistical measure that represents the proportion of the variance for a dependent variable that's explained by an independent variable or variables in a regression model.
Question 5. What are the assumptions required for linear regression? Answer: there are 4 major assumptions. 1. There is a linear relationship between the dependent variables and the regressors, meaning the model you are creating actually fits the data. 2. The errors or residuals of the data are normally distributed and independent from each other. 3. There is minimal multicollinearity between explanatory variables. And 4. Homoscedasticity. This means the variance around the regression line is the same for all values of the predictor variable.